Keegan can paddle his kayak 5 miles per hour in still water. He can paddle 6 miles upstream against a current in the same amount of time as it takes him to paddle 14 miles downstream. Determine the speed of the river's current. Whenever I have a problem like this, I prefer to use the table method. So distance equals rate times time. We have two trips. We have one upstream and one downstream. Okay, so we'll just label this one downstream and this one upstream. So he can paddle his kayak 5 miles per hour in still water. So I'm just going to say this is Keegan's rate. Keegan's rate is 5 miles per hour. So notice, so this is in still water. So he can paddle 6 miles upstream, so that's his distance, in the same amount of time as it takes him to paddle 14 miles downstream. Okay, notice it said in the same amount of time. It didn't tell us what that time was, but because it's the same amount of time, we can put T for both because we know whatever T is, it's the same. Now, I don't know if you've ever paddled on a river. This summer, I actually floated down the river a few times. And I know when I'm going downstream, I have that current to help me. Okay, so whatever he's going to have his speed that he paddles, but he's also going to have that current helping him downstream. Now, sometimes I had friends behind me upstream, so I might be trying to slow down, or they might be further down and they're trying to get upstream to me. And anyway, when you're trying to go upstream, it's a lot harder. It's a lot more work. And so that's going to be your effort, so your rate, or in this case Keegan's rate, minus the current, because that current is slowing you down. You have to paddle against the current. You have to work. You're just going to be going slower because that current slows you down. So that's one way that I think of the downstream and the upstream. I think of myself on the river, and that's just a really clear memory how much easier it is to go downstream with that help of the current. Okay, so we've got our table filled out. I notice the T is isolated, and so what I'm going to do is write distance equals rate times time, but I'm going to isolate the T. So if we divide both sides by R, we'll end up with T equals D over R. And I'm going to use this to write out each line of this table. So on the top line for downstream, I'll have T equals distance, which is 14, over 5 plus C. For downstream, I'll have for upstream, I'll have T equals 6 over 5, oops, doesn't want me to write anymore there, 5 minus C. Okay, well, since these both equal T, we know they also both equal each other. And so we can set those equal. We can say, okay, 14 over 5 plus C is equal to 6 over 5 minus C. We have a fraction equal to a fraction, and so we can cross multiply to solve. So we'll end up with 14, want to definitely put 5 minus C in parentheses, so that 14 is multiplied to both, equals 6 times 5 plus C, again in parentheses. We'll distribute this out, so 14 times 5, I'll get 70 minus 14C equals 30 plus 6C. Now at this point, we just need to isolate our C's and get our constant terms on the other side. So add 14C to each side. First, that becomes 70 on this on the left side equals 30 plus 6 plus 14 gives us 20C. Then subtract our 30, we get 40 equals 20C. Divide by 20. I'm worried I'm going to run out of space down there. Almost. So 40 divided by 20, I'm going to get C equals 2. So if you remember C, and I did this on purpose, I put C for the current so that when I got to my answer I could remember, oh, C is the current. So this tells me then the current is 2 miles per hour. Let's make sure, does this make sense in the context of this problem? Well, the current is slower than the rate, and so that's important. Otherwise, Keegan could not go upstream. So we want to make sure the current's always less than the rate that he is paddling. And another thing you could do is you could even substitute it in. So you could say, does 14 over 5 plus 2 equal 6 over 5 minus 2? And you could simplify that. We'd get 14 over 7 equals 6 over 3, which those both simplify to 2. So that tells us that that current is actually accurate. Now I'm just going to do a quick check, make sure we're answering the correct question, because sometimes they're asking for a different one, but this one says determine the speed of the river's current, and that is what we have done. So that would be your final answer there.